Welcome back to the Flip class. Okay, today I've got a lot to talk about, so I want to jump right into it. We're going to be talking about three-dimensional figures, 3D figures. There's some vocabulary words I want you to learn, which you'll see on this sheet, and just know that these are not all of the 3D figures, and not even all of the 3D figures we'll be talking about in class, but I just want to give you some examples. First one I want to talk about is a prism. A prism has two congruent parallel bases, and the other faces are all parallelograms. This is a prism, this is a prism, and the cylinder is also a prism. Now, when I talk about an edge, the edge, as you can see here, is the lines that form the figure. And that includes all lines that form the figure, even the ones, you see there's the dots back here that show you where the lines would be if you could see through the three-dimensional figure. Those are all included. Okay? The face is a flat surface. That is a face. It's the front face of this cube. Okay? And then a vertex is where points come together. Okay? If you have multiple vertex, that would be called vertices. All right? So, for an example, let's look at this cube. It has the front face, side face, the other side face, the bottom, and the top. Okay, so that's 4 sides. 1, 2, 3, 4, counting, and then 5 counting the front face. And then also that back face. If you were looking at this as a cube, it would be on the back side. So this cube has 6 in all. Oops. 6 in all faces. Okay? Let's look at edges. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, let's look at that again. As you draw it, having trouble with my program here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we're looking at 12 edges. Vertices. 1, 2, 3, 4, 5, 6, 7, 8. All the points where they come together. Okay, next thing I want to talk about. Pyramid. Pyramid has one polygon-shaped base. Okay, so one shape is the base. And 3 or more triangular faces that share a vertex. So, for example, here you have the triangle down below, and then they all meet at the same vertex. Here you have, looks like a parallelogram square below, 4 edges that meet at the same vertex. A sphere, okay, has no base and one curved surface. All points on the surface are the same distance from a point at the center of the sphere. So basically, think of a sphere like a ball. Like if you have a basketball or a globe, that's a sphere. Okay, I want to talk a little bit about volume. Volume is the number of cubic units need to fill a space. And I want you to focus on this picture, and you can find this if you want to look at it a little bit more closely on page 566. You need, if you look, they've filled this with these cubes, right? So we're talking about cubic units, cubes, right? You need 10 cubes to cover the bottom of this rectangular prism. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? You need 3 layers of those 10 cubes, because that's one layer, But as you fill it up, you go 1, 2, 3 high. So 3 layers of 10 cubes each to fill the prism. So it takes 30, or 5 times 2 times 3. Okay? Volume is expressed in cubic units. So, for example, this would be 30 either cubic centimeters or centimeters cubed. Okay, so let's talk about the volume of a rectangular prism. Okay, you see it's 3D, you see that it is a prism, has the polygon shape. Okay, now, it has the 2 bases, all that good stuff. If you look at this, to find the volume of a rectangular prism, you do length times width times height. So I have our length at 80 inches, our width at 36 inches, and our height at 20 inches. Okay, let's start by multiplying 36 times 80. 0 times 6 is going to be 0. 0 times 3 is going to be 0. I drop down my place value holder 0, my smiley face 0 there. Kind of looks more like a Nike symbol, but that's okay. All right, 8 times 6 is 48. Drop the 8, carry the 4. 8 times 3 is 24 plus 4, 2880. So I have 2,880, and now I need to multiply by 20. Okay, I know 0 here times all of those numbers are going to be 0, 0, 0, 0. I drop down my smiley face placeholder. 2 times 0 is 0. 2 times 8 is 16. Drop the 6, carry the 1. 2 times 8 is 16, plus 1 is 17. Drop the 7, carry the 1. 2 times 2 is 4, plus 1 is 5. So I end up with 57,600 inches cubed would be the volume of this rectangular prism. Okay, now if you're looking at a triangular prism, and I've drawn one here, made it pretty simple for us. Okay, you're looking at volume as base times height. Base, you want to take the 1/2 of the length times the width, and then multiply by the height. So in this case, we have 1/2, 5 times 4, times height of 9, because think about it if it was standing up, right? Okay, 5 times 4 is 20, half of that is 10, times 9 gives us, I'll write it up here up top, 90, and we'll say these are inches, cubic inches, or 90 inches cubed. Okay, now I want to take a look at the volume of a cylinder. Okay, volume of a cylinder would be pi r squared times the height. And this picture does a really good job of showing us what we're looking at here. So let's say, so we have our radius here, it's already drawn out for us, let's say that that was 4 centimeters. Okay, and let's say that our height was 15 centimeters. Okay, well, let's do a little work. R squared, I know, is going to be 4 squared. 4 squared, 4 times 4 is 16. And I'm going to have to multiply that by pi. Let's do the math. 6 times 4, 24. 6 times 1 is 6, plus 2 is 8. 6 times 3, 18. Drop a 0. 1 times 4, 1 times 1, 1 times 3. Let's add 4. 8 plus 4 is 12. Carry the 1. 10. Carry the 1. 3, 4, 5. Big number, but also remember 1, 2 decimal spots, 1, 2 decimal spots. So I end up with 50.24, but that's not all. That's just r squared is 16 times pi, so we took care of that. Now we still need to multiply by the height, which is 15. Make a little extra room here, okay? So we have 50.24 times 15. Excuse me. 5 times 4 is 20. 5 times 2 is 10. Plus 2 is 12. 5 times 0 is 0 plus 1. 5 times 5 is 25. Place value holder 0. 1 times 4, 1 times 2, 1 times 0, 1 times 5. Let's add. We have 0, 6, 3, 5, 7. I have two decimal movements, so I go 1, 2. And that would give me a volume of 753.6 centimeters cubed. Okay, and we're going to stop right there. I know I've thrown a lot of information at you. Again, as usual, we can break these down into smaller parts, which we'll do in class, but I want you to have it all in one place. You can fast forward, find the formulas that you want, find the examples that you want to watch. So this is now a tool that you can go back and forth and look at as you need be. Okay, can't wait to see you in class. We'll check this out and we'll do some work. All right, see you then.